This video, we're going to do the elimination method for systems of equations. And so our learning targets here are determine the solution to a system of equations using the elimination method and analyze and interpret the meaning of the solution, whether we get one solution, no solution, or infinite number of solutions. So we're going to work through one example. Actually, let's go back one slide. When is this method best? This method is best used if we are in standard form. All right, and so you'll see ax plus by equals c, and our second equation would also be in this form, so dx plus ey equals f, and these are just coefficients a, b, c, d, e, and f. Notice your x's are lined up, your y's are lined up, your equal signs are lined up, and then your constants are lined up. Okay. Graphing would be best used if they're both in slope-intercept form. Substitution would be best used if one of the equations was y equals mx plus b, and the other equation was standard form, or it could even be slope-intercept form. Elimination, again, best used if it's in standard form. If it's not in this form, you're going to have to get it into that form. All right, so we're going to look at this example, 2x plus 3y equals 5. That's our first equation. 5x minus 2y equals 22. And elimination is based on the fact that an equation is balanced, right? So the left side is equal to the right side, always. And so you can always add to the left side as long as you add the same amount to the right side, or if you multiply the left side, you have to multiply the right side by the same amount. So we're going to choose a variable to eliminate. And in this case, I'm going to choose the y's to eliminate, okay? So I'm going to eliminate, let's make that look like, we're going to eliminate the y, okay? So what we're going to do is we're going to multiply, because these aren't opposites yet, right? If I add 3 and negative 2, I don't get 0. So we're going to multiply by a value that's going to get opposites. And so we're going to look at 3 and negative 2, and we're going to say, well, what number do both 3 and 2 go into? The smallest number is 6, right? So we're going to force this 3 to be a 6. How do we do that? Well, all we need to do is multiply the top equation by 2. When we multiply the top equation by 2, that's going to give us 4x plus 6y equals 10. We're going to do the same thing with the bottom equation, but now we're going to need to make this 2 into a 6. And see how there it's already a negative? I'm going to multiply so that doesn't change, right? I want opposites, meaning one positive, one negative. And so to make a 2 into a 6, we're going to multiply the bottom equation, our equation 2, by 3. And this is going to give us 15x minus 6y equals 66. And if you notice here, right, we have our forced opposites. We didn't change the value of our equation because we multiplied everything on the top by 2 and we multiplied everything on the bottom by 3. All right, and so this is going to be what we're going to use in our next part. Okay, so we did our multiplication to force opposites. Down here. So we're going to combine equations, right? We can add the same thing to both sides. 15x minus 6y is the same thing as 66. So if I add 15x minus 6y to the left-hand side here, I need to add something to the right-hand side that is equal to that. Well, 66 is equal to that. And so our next step is we're going to combine our equations by adding them together. We're going to add our two equations together. So 4 plus 15 gives us 19x. 6y plus negative 6y, those cancel, right? They eliminate each other, hence the elimination method. Equals 10 plus 66 gives us 76. And so what happens once we eliminate is you get an equation, a one-step equation, 19x equals 76. if you don't eliminate one of the variables, you made a mistake. And so now we're going to solve for the remaining variable. To solve this, we divide both sides by 19, divide by 19, and so x equals 4. Okay? And so we now know what our x value is. All right? Remember, when we solve a system, we're looking for an x and a y. So we're going to remember that x equals 4. Let me actually just copy this whole thing. All right, so now we're going to back substitute. Now, to back substitute, we're going to go back to one of our original equations, or we could use these equations. So if we go back to our original equation, 2x plus 3y equals 5, I'm going to plug in my x value. My x value is 4. That's going to equal 5. So we get 8 plus 3y equals 5. 3y equals -3. And so y equals -1. So we back substitute to get our equation, or to solve for the other variable. And so here we're going to get our x value was 4, and our y value is -1. And we can go back to the original. We can check our answers. We could check it into these two equations. It's going to work for the first one. So 16 minus 6 does equal 10. And then 15 times 4 is 60, minus 6 times -1, so that's 60 plus 6 does give us 66, and so that is a check. Just to note, if both variables cancel out, we get no solution if it's a false statement. So this would read something like 3 equals 4. That is a false statement. There is no solution. A true statement, we get an infinite number of solutions. Here you would get something like 12 equals 12, 0 equals 0. Those are true statements. They are always true, and so we get infinite number of solutions. Remember, we want to write infinite number of solutions. This would be the same as if we were to graph them. Our two lines would be the same line. Our false statement, the no solution, means our two lines would be parallel lines. And so here's an example. This is number 4 on the back. Pause the video, try it, and then you'll see my answer. And yeah, that's the elimination method. All right, so if you look here, I decided to eliminate the x's. I multiplied the top by 3, the bottom equation by 5. This gives me 15x minus 21y equals 36. Bottom equation becomes -15x plus 20y equals -35. I forced opposites on my x's. So when I combine my two equations now, we get 0, -1y equals 36 minus 35 gives us 1. Dividing by -1, y equals -1. Now we're not done. We need to go back and substitute that in to find the x value. Right here we found the y. And so I'm going to pick either of these equations. I'm going to choose to do the bottom equation. I'll use green here. -3 times x plus 4 times -1 equals -7. -3x minus 4 equals -7, adding 4 negative 3x equals negative 3. And last step, x equals negative 1. And so our ordered pair is negative 1, negative 1. Now, we could have done this eliminating the x's. I'm not going to do it here, but if you did do this way, you would multiply, what color? I'll use blue. You would multiply the top equation by, right, negative 7 and 4. We have the opposites. We would multiply this equation by 4, and we would multiply this equation by 7. Our opposite coefficients would be negative 28 and positive 28. You're going to get the same result. You would find x first in this case, which would be negative 1, back substitute it, and you would get the y value of negative 1. And that's the elimination method.